Solving a trigonometric equation by factoring is really no different than solving a normal quadratic equation by factoring. And so the first step you'll always want to do when solving by factoring is rearrange your equation so it's set equal to 0. So I've gone ahead and done that already. I've just added 2 over. And so now I want to factor this trinomial that's written with cosines in it. Well, what I'd recommend you do, especially at first, is rather than think of this as cosines, just replace all those with x's. And so think of this problem as just x squared minus 3x plus 2 equals 0. And so that may help you factor these, especially when you're new to these. And so factoring something like this, it's a matter of figuring out what multiplies to 2 and adds up to negative 3. And so the two numbers that would do that would be x minus 2 and x minus 1. And so what I tell people is if you can factor a quadratic, you can factor a trigonometric quadratic as well. And so if you need to, now just go ahead and see take a look at what you found and sort of translate that back into stuff with cosine in it. So every x becomes a cosine. So if I rewrite back to my original problem, rewrite this, I'd have cosine of theta minus 2 times cosine of theta minus 1. Do you see the connection? And some of you can probably factor this without thinking of it in terms of x, and that's totally fine. So now what I want to do, since I have two things being multiplied together to equal 0, I know that one of those two things must be 0, and so I have two equations to solve now. Either cosine of theta minus 2 is equal to 0, or cosine of theta minus 1 is equal to 0. Oops. And so now solving those two mini equations, I'll start with the one on the left. Cosine of theta would be 2, and so I do this just like I would do any other problem that we've looked at earlier. And you can go back and refer to some previous videos if you need to. I would look in my trig chart for a cosine ratio of 2, and it would turn out I didn't have one. I could also try doing an inverse cosine of 2 on a calculator, and I'd see that I get an error. You can't have a cosine ratio that's bigger than 2, and so this side of the problem is actually undefined, and so this side doesn't get us any answers. There's no angles that have a cosine or a sine ratio of something bigger than 1. So that gets us nothing. That was kind of a bust. If I try the other side, though, I'd have cosine of theta equals 1, and looking in my trig chart under the cosine column, I can see that there is an angle that does that. An angle of 0 gets me a cosine of 1, and that's the only answer this time. So there is my one and only solution to this problem. Theta is equal to 0.